One example of a redox reaction in which reduction and oxidation take place simultaneously is what is known as a displacement reaction. A displacement reaction occurs when one substance which has formed a compound is kicked out by another. For example, if you bubble chlorine gas, which as always has the chemical formula Cl2, as halogens exist as diatomic molecules, through a solution of potassium bromide, you will form a solution of the potassium chloride salt and bromine molecules, which, as bromine is a liquid, will also be aqueous. They'll dissolve in solution. This reaction is an example of how a more reactive halogen can displace or kick out a less reactive halogen from an aqueous solution of its salt. As the reactivity of the halogens decreases as you travel down the group, chlorine is more reactive than bromine. Therefore, the bromine, which exists as bromide in the potassium bromide salt, will be replaced by chlorine in the form of chloride. As we'll see in a minute, this is also an example of a redox reaction. In order to write out equations for what's happening in this reaction, we need to remember that an ionic equation will only show the species that change during the reaction. For example, if this diagram represents our reaction, our blue circle represents our potassium, which is in the form of a K+ potassium cation, both in the reactant, potassium bromide, and also in the product, potassium chloride. This species is unaffected by the redox reaction. It exists as a K+ cation before and after the displacement. And as redox is the loss or gain of electrons, we can see that this potassium cation hasn't been reduced or oxidised, as it has the same number of electrons when the reaction starts as to when the reaction finishes. In redox, ionic equations will only show substances that have been oxidised or reduced, and therefore we wouldn't expect this K+ cation to appear in ionic equations for a redox reaction. For example, let's think about what's happening in the example that we introduced. We can start by writing out a reaction again in full. So on the left-hand side, reaction side of the arrow, we have Cl2 plus 2 lots of potassium bromide, or KBr, which we can write as 2K+, 2Br-, in order to give us 2 lots of KCl, or potassium chloride, which we can write as 2K+, 2Cl-, and our Br2 bromine molecule.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.